Welcome to another session of microengineering. We are continuing with stub matching. This time we are going to have series stub matching. It is similar to shunt, but only difference is that in case of shunt we used to take admittance value. Here we will be continuing the same procedures, but we will not be taking admittance. We will be working in impedance only. So VSWR value will be VSWR circle will be plotted, but admittance will not be taken, and the rest of the procedure remains the same. Now let us see how we can do it. We are taking a problem of ZL is equal to 100 plus J80, that is matched to a 50 ohm transmission line. So for duty number 1, if the step number 1 which we do is normalize the impedance, that normalize the impedance, when you do it, you can see over here that we have normalized it. It is 2 point plus J 1.6. How do we get that? 100 plus J80 upon 50, that value comes out to be 2 plus J 1.6. You're going to plot this ZL, and this ZL, then you can plot the VSWR circle also. That is not for finding admittance. We are just going to plot it, and this ZL in terms of lambda you are going to find. I hope you remember how we do that. We take the scale, we keep the scale in such a way that the line has to pass through center of Smith chart, means the unity gain circle, that point center 1, and this point ZL, and outside the Smith chart, that straight line. So that value in terms of lambda has been written as 0.209 lambda, which is marked over here. Then after that, the VSWR is already plotted. You're going to again highlight the unity gain circle. Then you will see again it is intersecting at 2 points. In clockwise direction, the nearest point to ZL will be taken Z1. The other point will be taken Z2. After finding Z1 and Z2, we need to find about D1 and D2. I hope you remember the way we did for short circuit stuff. Shunt configuration, D1 was the distance in clockwise direction that you will observe in the problem while we are solving. That is coming out to be 0.327 lambda minus 0.209, and answer comes out to be 0.11 lambda and 0.465 lambda. We'll see that in the problem. And since it is a series open circuit point, this time same way, whenever the value is greater than 0.25 lambda, you need to subtract it, and if it is less, we need to add 0.25 lambda to it. The same procedure has been applied over here too. Okay, now let us see the problem, how we are going to solve it. Now to start with the problem, let us first plot the impedance point. So how do we plot the impedance pointers? The impedance point given to us is how much is the point? Impedance is 100 plus J80. So while solving it becomes 2. So this is my 1, right? My unity gain circle. So 1, and then becomes 1.2, 1.4, 1.6, 1.8. Yeah, this is my 2. So this 2 circle, I'll just highlight it. It's not required. We just have to find the value. It's just for your reference. I'm just highlighting this circle. This is the circle I'm interested in. Okay. I just have to find where is plus J 1.6. So where do you find impedance values? It is always inside. So this is my 1, this is 1.2, this is 1.4, this is 1.6. So you can see this is going down. I will not highlight it, just for your purpose I'm doing it. Otherwise we don't do this. We just take that point. Yeah, this is it. You're supposed to find the VSWR circle. If it would have been shunt configuration, you had plotted VSWR circle, found out the admittance 2. Plus please note this is series configuration. We will be still working in ZL point, not YL point. To find VSWR circle, how do you do it? I hope you remember. Keep the center of the compass at unity gain. This point, this is your radius. I hope you remember this. This is the radius, and then plot the circle. So what happens when you plot the circle? I'll show you in the next one. When you plot the circle, this is what happens. When you plot the circle, this becomes your point. So this is your ZL point. And I told you in clockwise direction, you take the first point. So in clockwise, may I say the clock moves in this direction? Right? As a result, this point becomes your Z1. Can you see over here? It's marked. And this becomes your Z2. Because in clockwise, you go above. So this becomes your Z2. I hope it is clear now. What do you mean by clockwise? Now, how do you find D1? Do you recollect how we did in shunt configuration? So in Z1, how did you find it? This in terms of lambda you are supposed to find. That is what they have done in terms of lambda. This Z1 point in terms, this is Z1. Yeah, correct. So this is Z1 point. So this in terms of lambda value you should know. So this in Z of lambda value, it is coming 0.327. It is given in your notes also. It's coming 0.327 lambda here. And your ZL point already I have told you in terms of lambda was coming 0.209. So D1 as marked here, I'm just marking it for you all outside, is here. So what is D1? Somebody asks you, it is nothing but greater minus smaller. So you will just find in clockwise direction this D1 point over here, whatever value you got, you have to subtract it from this ZL value. So that value is called as D1. The value is given in the notes. So you can just check it out over here if you want. If you're doing it along with me, you can check that this D1 is 0.327 lambda. This value will come 0.327 lambda. Okay, and this will be subtracting from your 0.209 lambda. Answer will come 0.118 lambda. Now to find D2 is very interesting point what we are going to do. Now D2 how will you find? Now D2 also has to be found in the same way because you have found D1 as distance between ZL and D1. Now tell me what is D2 then? D2 will be, you are going to find from here, please note, from here, I'm just highlighting, this is your ZL point. This is your ZL point. I'm saying this is your ZL point. So you will take the entire, full. It goes like this. Screen is small. Full, entire thing, entire. We'll just mark it from here. Entire thing up to here. That is your D2. That is your D2. So now question that comes is, how will you find this D2? There are multiple ways of doing this. One of the easiest way is that I'm supposed to find the distance between these two. I hope you get it. I'll just mark something, some color. I'm supposed to find the distance between, like this. I want to know this distance. So how do I do it? Very simple. I'll take 0.5 lambda. Why 0.5 lambda? Because this is entire circumference of Smith chart is 0.5 lambda. From this 0.5 lambda, if I subtract Z2 part, see, why am I subtracting my, sorry, not Z2, ZL point? Meaning, from here, I'm just look at this blue color thing. I'm marking at my this one. Can you see it? From here up to my ZL point is how much? It is 0.209 lambda. We have seen it. This is 0.209 lambda. So from 0.5 lambda, if I subtract this 0.209 lambda, how much remains? The remaining part. This much part remains. If you subtract the blue part from the entire thing, what remains? The remaining part remains. So this remaining part which is there, that thing, if you add it to this remaining part, I'm just highlighting what remains. This remains. Am I clear? This purple thing remains. This purple thing remains. Now what do I need to find? The distance from this point. I'm trying to find what? D2. Can you see the red color big one circle? I'm trying to find D2. So for finding D2, I have found out the distance from purple line. Can you see this purple line? I've reached till here. What exactly is remaining then? I just have to add the remaining part as 0.174 lambda. What is the 0.174 lambda? The remaining part. Meaning, I'm taking the purple line again. So I'm just going to add that to this. So the total D2 will be addition of, that is 0.5 minus the position of ZL point, subtract from there and add the new existing Y2 point. So totally you will get the answer as 0.405. That is the more interesting. The concept over here is to find D1 or D2, you always have to take the distance in clockwise direction and find the distance between the two. In clock you have to follow. That is the most important thing. To find L1 and L2, I've come back to the similar circuit. To find L1 and L2, first you need to find Z1 point, if you remember that. To find Z1 point, where is your Z1 point? This is your Z1 point. Am I right? Clockwise direction, right? This is your Z1 point. This Z1 point, complex conjugate I am supposed to write. Do you remember that? The real value is always 1, but the imaginary part has to be cancelled out. So complex conjugate when I am taking, that complex conjugate point will be always Z2 point. That in terms of lambda I should come to. In terms of lambda, that value is coming as 0.15 lambda, if you remember that the value is less than 0.25 lambda, when you add it to the circuit, you will get this value as 0.4 lambda. That is what is written in your notes. So just, that is why this they have marked it already as L2. This is your, okay. So this point will come, your L1, sorry, first leg. The L2 point will be exactly similar, meaning you will find Z2 point. There is your Z2 point. You will find from Z2 point. This is your Z2 point. Complex conjugate of this will be Z2 here, Z1 point. Find in terms of lambda, just take a straight line. Whatever value you get, that value is greater than 0.25 lambda. Subtract 0.25 lambda from it, the remaining value will be your L2. Am I clear? So this is how you find out your design. Now, this is for open circuit. Now, suppose the same question they had asked you for short circuit. What will you do? Same way, continue with the problem, but only difference is that you will not subtract, neither add. The important points which was there for shunt configuration, same thing continues over here. But for the open circuit, when you're doing series combination, whenever it is greater than 0.25 lambda, you need to subtract. Whenever it is less than 0.25 lambda, you need to add. But if the same question of series combination is asked for short circuit, do not add or subtract 0.25 lambda. Whatever answers you get, the answers remain like this only. Meaning, your value of L1 will remain 0.15 lambda and value of L2 will also remain 0.348 lambda. I hope you understood the lecture. You can repeat the problem, same problem which I have given, but this time by using series short circuit. Thank you. I hope you are seeing the final circuit diagram. This time it is not short circuit, it's open circuit. You can see over here. So open circuit point being shown here. I hope you can see this open circuit point. Please do not mark these two things. It's not needed for you. It's not needed for us. We're supposed to draw entire circuit except these points. Rest all you can draw. These are the two solutions how we are going to draw it. This is L1, D1, both being marked. L1, D1 and L2, D2 both are marked in two different solutions of the same circuit. This is how your final answer should stop. Thank you so much.